Microsoft has established significant leadership in the AI industry by acquiring 485,000 Hopper chips from NVIDIA, a quantity twice as large as its direct competitors. This massive acquisition, which represents approximately 20% of NVIDIA's revenue in the last year, positions Microsoft as the undisputed leader in the race for AI infrastructure. In comparison, Meta, the second largest buyer in the United States, acquired 224,000 units, while Amazon and Google follow with 196,000 and 169,000 chips, respectively. The Asian scenario presents a particular dynamic, with ByteDance and Tencent each acquiring approximately 230,000 chips. However, due to export restrictions imposed by the United States, these companies received modified versions called H20, which have reduced capabilities compared to the full Hopper models used by American companies. This situation illustrates the geopolitical complexities that permeate the advanced technology market. Want to understand everything? Then watch the video until the end and I'll explain it to you. But first, leave a like and subscribe to the channel. That way, you'll stay informed about the latest news on artificial intelligence. The financial impact of this race for AI chips is substantial, with technology companies globally investing about $229 billion in servers this year alone. Microsoft leads these investments with $31 billion, followed by Amazon with $26 billion. A particularly relevant fact is that 43% of all this investment was directed towards NVIDIA products, consolidating its position as the leader in the AI processor market. NVIDIA has greatly benefited from this growing demand, reaching a market valuation of over $3 trillion. The company is focused on developing the Blackwell NVLGB200 system, the successor to the Hopper line, with a production peak expected for mid-2025. Analysts predict an increase in the company's foundry capacity from 56% in 2024 to 60% in 2025. However, technology companies are not just relying on NVIDIA. Microsoft has started developing its own Maia chips, having already installed 200,000 units. These chips represent a significant advancement in the company's ability to design specialized hardware, featuring 105 billion transistors, although it's 30% less than the 153 billion found in AMD's MI300X. Maia is notable for being the first fully liquid-cooled server processor built by Microsoft. Meta is also diversifying its suppliers, having acquired 173,000 units of AMD's MI300 processor, while Microsoft invested in 96,000 units of this same chip. This diversification strategy demonstrates an attempt by companies to reduce their dependence on a single supplier, even as they continue to make substantial investments in NVIDIA chips. The Stargate project emerges as a particularly ambitious initiative from the partnership between Microsoft and OpenAI, with a potential investment of up to $100 billion. This project aims not only to expand the company's processing capacity, but also to develop its own solutions that can reduce dependence on external suppliers. The magnitude of this investment demonstrates Microsoft's commitment to maintaining its leadership position in AI development, especially after the success of integrating ChatGPT into its products. The physical infrastructure necessary to support this massive expansion in processing capacity has required significant innovations. Microsoft has developed a specially designed single-rack system to house the Maia server blades, including a sophisticated liquid cooling system that works similarly to an automotive radiator. This cooling solution is crucial, considering the intense heat generated by AI processing, which exceeds the capabilities of traditional cooling systems. NVIDIA's Hopper chips, particularly the H100 GPU model, have proven essential for complex AI training operations. Their superior processing power makes them especially valuable for developing large language models and other advanced AI applications. Demand for these chips has reached such high levels that some units have been traded for over $40,000 on the secondary market, evidencing the critical shortage of these components. Microsoft is actively using this expanded infrastructure to power several critical services, including Microsoft Teams, SQL Server, and its AI initiatives. Initial tests with the new Maia chips demonstrate performance up to 40% higher than the commercial ARM servers currently in use in the company's data centers. This significant performance improvement is crucial for maintaining competitiveness in the cloud services market and supporting the growing processing demands. The collaboration with OpenAI has been particularly significant in the development and implementation of this infrastructure. Sam Altman, CEO of OpenAI, expressed enthusiasm for the Maia chip designs, having worked together with Microsoft to refine and test the chip with their most advanced models. This partnership demonstrates an integrated approach to hardware and software development, aiming to optimize the performance of the most sophisticated AI models. Microsoft is actively participating in a group that includes AMD, ARM, Intel, Meta, NVIDIA, and Qualcomm to standardize the next generation of data formats for AI models. This collaboration through the Open Compute project demonstrates a coordinated industry effort to establish common standards, even in a highly competitive environment. The company is sharing its rack designs with industry partners, although it maintains the specific designs of the Maia chips as exclusive property. The integration of ChatGPT and other AI technologies into Microsoft products, particularly the Bing search engine, represents a significant practical application of this infrastructure investment. The company is using its expanded processing capacity to train and operate increasingly sophisticated models, including GPT 3.5 Turbo. This integration is transforming the way users interact with Microsoft tools, from productivity applications to cloud services. Technology companies are increasingly investing in the development of proprietary chips. Google and Meta have each already deployed about 1.5 million of their own chips, while Amazon has implemented approximately 1,300,000 units of its proprietary chips. This trend indicates a significant shift in the market, with large technology companies seeking greater control over their processing infrastructure. Microsoft's massive chip acquisition has significant implications for the Azure cloud services market. With this expanded infrastructure, the company is positioned to offer more robust and efficient services to its corporate customers, potentially altering the competitive dynamics in the cloud computing market. The ability to process more complex AI workloads and run more sophisticated models represents a significant competitive advantage. The development of Maia chips represents a significant evolution in Microsoft's hardware capabilities. The company has a long history in silicon development, having collaborated on Xbox chips over 20 years ago and co-developed chips for Surface devices. This accumulated experience was crucial for the development of the new AI-specialized chips. Export restrictions imposed by the United States have created a complex dynamic in the global AI chip market. The modification of H20 chips for the Chinese market illustrates how geopolitical considerations are actively shaping the development and distribution of advanced technology. This situation is creating a significant technological divide between Western and Eastern markets, with potential long-term implications for global AI development. The impact of this race for specialized chips extends beyond traditional data centers. Microsoft has developed a comprehensive approach to optimize every layer of its infrastructure, from chip design to server architecture. This optimization includes the ability to control performance and power consumption per core in each virtual machine, demonstrating a focus on operational efficiency beyond mere processing capacity. The technical challenges associated with developing and implementing these chips are considerable. Issues such as efficient cooling and thermal management have required innovative solutions, as evidenced by the liquid cooling system developed for Maia chips. These infrastructure innovations are crucial for enabling higher server density with greater efficiency, while staying within the physical limitations of existing data centers. The concentration of computational resources in the hands of a few companies raises important questions about the future of AI innovation. With the major tech players controlling a significant portion of the available processing capacity, concerns arise about access to advanced computational resources by smaller companies and research institutions. This dynamic can have significant implications for the future development of AI technology. Microsoft's investment in NVIDIA chips and the development of its own processors reflect a dual strategy, maintaining leadership in the present while preparing for a future less dependent on external suppliers. This approach demonstrates a sophisticated understanding of the current and future needs of the AI market, as well as the challenges and opportunities that arise with the rapid development of this technology. How do you assess the impact of this concentration of computational power on the future of technological innovation? What will be the role of smaller companies and startups in a market dominated by giants with such vast resources? Share your perspectives on these crucial issues for the future of technology in the comments, and let's debate the subject. If you liked the video, leave a like and subscribe to the channel. That way, you'll always receive notifications of new videos. Until next time.